Hi friends, linear mixed models are very useful when we have different patterns for different groups within the same data. Let's understand this through a very simple synthetic example. Now let's just pretend we have weight on y-axis, age on x-axis in some arbitrary units. And the weight is increasing with the age. And here we have two groups. Let's say this is male, this is female. So for both, the weight is increasing with the age, but at a different rate, right? For male, the slope is higher, whereas for female, the slope is lower, right? So we have a very simple data set with two independent variables, age, which is this x, and sex, which is this group G1 and G2, or male, female. And we have our target variable, which is weight, y. All right. Now let's try to model this data using simple linear regression. Okay. So we have two features. This is our target variable. And since group is a categorical one, we get the dummies. And this is how x looks like. So the age, it will remain as it is. And here we ask, is this data point group 2 or not? So this will have true or false or 1 or zeros. So we fit a linear regression and here we made the predictions. Now the model looks like this, right? It will have a single intercept and it will have two coefficients, one for each of the two features, which is x, and the second one, is it group 2 or not? So the prediction or the formula looks like this. First, we have the intercept plus we have the feature value and its coefficient. And then we have the second feature and its coefficient. But our second feature is simply 1 or 0. If it belongs to group 2, it's 1, otherwise it's 0. Okay, so the effect of this second coefficient is simply an upward shift if it belongs to group 2. All right, so here we are plotting our raw data along with the predictions. So this is for group 2 and blue one is for group 1, and then the continuous lines are the predictions. Now, as you can see, we have underestimated the slope for these orange points and overestimated the slope for the blue points. That's because we can have only one slope with the age in linear regression models, right? So that's why the difference between this data point and this data point, this data point and this data point is exactly the same, and that is equal to this coefficient for the group 2 variable. Okay, so I hope the shortcomings or linear regression model are clear to you when we have different pattern for different groups within the same data set. Now let's see how we can address this issue using this linear mixed models. All right. sklearn, it doesn't have these models, so we are going to use stats library. So the API is different and they have somewhat these weird syntax. Okay, so this is our target variable and this is our input variable or independent variable x or age, and then we are saying we have two groups, and more importantly, with this formula, we are saying each group can have its own slope as well. Okay, so this one says each group can have its own intercept, and then this one says each group can have its own slope as well. Okay, so we fit the model. Now the model will have two sets of parameters. One is called fixed effects, the second one is called random effects. Now from the model we are accessing this fixed effects parameter. This is just so that we can easily see the values. So we have one overall intercept for all the data and slope again for all the data. The interesting thing is the random effects. So we access the random effects, again just reorganizing the data so that we can easily see. Here we have for each group G1 and G2, we have its own intercept as well as its own slope. Okay, now in this case we have only two groups, so the only difference is this sign. But you can imagine, let's say we have 10 groups. So in such a case, these intercept and slope, the values are also different, not just the signs. Okay, and then the prediction, it is the combination of the fixed effects and the linear effects. Okay, for example, the fixed effects, it's the overall intercept plus the feature value multiplied with its quotient. So it's this 222 plus the feature or the age multiplied with its coefficient or slope 59. And then comes the random effects. Now the random effects are different for each group. So if it's group 1, if the data point belongs to group 1, then its own intercept plus the feature times the slope or the coefficient. If it's group 2, again its own intercept plus its own slope. And the final prediction is fixed effects plus random effects. Okay, so here we wrote a function. So instead of hard coding this value, we are doing exactly the same, but just using the parameters. Okay, now it will become clear through this graph. So here all I did is I access the fixed effect parameter, random effects parameter, and for each value and each group I computed what is the fixed effect, what is the random effects for each group, and the total for each group. Okay, so these data points is our raw data. So these filled circles. So for group 1 the orange, and for group 2 we have the blue data points. So this one and this one, the points. And then in this linear mixed model, we have the overall fixed effects, right? So the overall fixed effects, which is this green line. Okay, so as you can see, it fall somewhere in the middle. So this one, it tried to satisfy or do the best fit for both these data points. And then for each group we have its own random effects. So for group 1, these diamond points are the random effects. So the total prediction, as we just saw, is the sum of fixed plus random. So to the green curve we add these diamonds so that we get this continuous orange one, which matches exactly with, or which does the best fit for the orange data points. Similarly, for the blue points, the fixed effects remains the same, the green curve, but this time the random effects, this is what we have. So we sum the green curve with these blue diamond points and we will get this blue continuous line. Okay, which matches very well with the raw data, right, or our target variable. So I hope it became clear to you how by allowing both the slope and intercept to vary for each group, we are able to accurately model this data using a single model, right? Now, here for simplicity, we have only two groups, but you can imagine we can have as many groups as there can be, right? All right. One more thing I want to mention to you is, now here you have some flexibility in how you define your formula. As I mentioned, if our formula is only this, which means each group will have its own random intercept only. If we include this one, each group will have its own random slope also for this feature x. Now we can have the same thing for multiple features as well. So as you will see, things can become more complex, and we have a lot of freedom to allow which features can have their own intercept as well as their own slope. Okay. It's a very interesting concept. I hope it becomes clear to you. Thank you very much.